You know, when Daniel Cook was out, my kid was so much more interesting than him. And other people would be like, why isn't your kid doing Daniel Cook? And I was like, I don't know, man, because Daniel Cook, that kid was a puke.
Because he's typecast.
But to be fair, Daniel Cook no longer has a career. I don't know what he's doing now. I used to have a buddy named Daniel Cook. And when Daniel Cook got famous, I Facebooked my buddy Daniel Cook. He's like, what are you doing today, Daniel Cook? And he responded back, go get some pho. But not really. Get what I'm saying?
I got you.
Okay.
Fam.
Okay, here we go. Seriously, folks. It's math time. Equation. What is an equation?
Something equals something.
Thank you, Bryce. In more mathy terms than what Bryce just said, which I will repeat for those of you that are still talking about playoff hockey. An equation is something equals something, right? In math terms, it is
numbers and variables equals numbers and variables.
An expression which equals another expression. Okay? You have an expression equals another expression. And our job is to find the unknowns that make the equation true. And that's our job, but what do we have to do to accomplish that? It means we have to isolate the variables. No matter what form our equation takes, the goal is always to isolate the variables. We started you guys out on this math path in grade 6-ish, grade 7-ish in Canada. Actually, we started you on it in kindergarten, but we didn't call it algebra until grade 7, so you would be good and scared of it by the time you got there. It started with these. And every one of you, because you were taught, most of you went to school in Canada, are taught how to do this, and you will tell me that the answer is okay.
I thought you were joking.
So the answer is 6. Good job, Canadian math programs. Yes, the answer is 6. And then, hopefully, your teacher asked you why. And then 99% of you said, because 6 plus 3 is 9, Mrs. Bad Crumble. Duh. Which is totally the wrong answer. Why is this answer 6? Because 9 minus 3 equals 6. That is why this works. Now, all of you refuse, when it is a one-step equation, to do this. You refuse to show me that work. So when you graduated from that to this, 3x plus 7 equaled 19, you started to have a little bit of trouble because you refused to show the work on the millions of questions that were this. So you got to here and then, okay, you finally realized your teacher wasn't lying, and it's easy when you show work. You started showing some work and you started being able to do it. Then your teacher added this. And then you were like, ugh, and you still wouldn't show work for a while. You tried to do it in your head because you thought you could do it. And then eventually you realized, oh, showing work makes it easier, and you started to show work. Then your teacher did this. And then you were screwed. Almost all of you. Because you refuse to show work. Well, now we're at this. Fraction equals something. Again, if you try to do this without showing all the work, you will not be able to. All right? So please make sure, pretend like this is grade 6 and you're actually going to show the work that your teacher shows you how to do. Then you will find this to be easy. If you insist on trying to find shortcuts and do stuff your own way at the beginning, you are going to be in trouble. Okay? Now, when you get something like this, there are many shortcuts you can take to solve that. But most of you were probably taught something similar. Start with the letters, start with the smallest letter, and deal with that. So you would do minus 3x, then you would do minus 3x, then you would have 7 equals 2x minus 3. Then you would go to the numbers, plus 3, 10 equals 2x. Then you would divide by 2, and x would equal 5. Most of you should be aware that that is how most of you were taught to do algebra. Right? Most of you have moved past that, and that's fine, but that is essentially what you're doing. Many of you would just move these things now and do it in your head. That's fine too, but this is what you're doing. Make sure you are actually good at that right now. And how do you get good at that? By remembering how you were taught to do this stuff back in the old days. All right? Now, when you are given a rational equation, you need to be aware that that is a rational expression, and I'm writing the rational expression as a fraction, so you're used to it, equals another rational expression. Now, just like in a regular equation, I can have more than one thing on both sides, okay? Just like I had up here, 3x plus 7 equaled 5x minus 3. I have numerous things on both sides, yes? But I do a whole bunch of algebra to break it down, so it's one thing equals x. We're going to do the same thing here. I can have any number of rational expressions on either side of the equal sign. Is everybody okay with that? All right. So here is what you do. The first thing you do should be the first step you do in every single math problem you face, which is what? Not factor. That's the wrong word. You should read the...
Checkmate.
Yes. Your first step in solving, once you have read the question, Nav, should be simplify. Now, in rational expressions, that usually means factoring, yes? But it doesn't always. So I'm going to write simplify. You should always simplify. Now, I remind you again that for grade 11, this is usually, nice spelling, usually factoring and Joel's specialty, canceling. Usually. Everybody cool with that? Once we factor and we cancel, we've got to check our non-permissible values before we do any canceling. Non-permissibles. Okay, everybody good? Now, number 3 is where it starts to get weird. Okay? At number 3, we are going to find our common denominators. And our goal here is to cancel any of them in order to eliminate, please highlight eliminate all fractions. Step 3 should be where your fractions disappear. Okay? Step 4, we use regular algebra. We use regular algebra because our fractions are gone. And step 5, we've got to check 2 things. What are the 2 things we need to check? Because in step 5, we are at this point. X equals something. We have to check non-permissibles and extraneous. Do you remember extraneous roots? That was what we had in, for example, if we were throwing the ball off the roof, we would get 2 roots, yes? But one was a negative time. That's an extraneous root. We remember these, yes? All right. So let's try this on this extraordinarily simple one. Step 1. Is there any factoring to do to simplify that? No. So step 1, we're going to check for factors. There's none. So we go on to step 2. Step 2 is non-permissible values. What can x not be? X can't be 0. Great. Step 3 is our common denominator. Why do I need a common denominator there? Because I'm doing a fraction, addition, or subtraction problem. Yes? So what is my common denominator? 4x. So I can now rewrite my equation as everything over 4x. Yes? Is everybody cool with that? That's my common denominator. Is everyone good with that? Okay. So now I'm going to use my highlighter. What does that denominator need to be? 4x. What is it right now? 4. So this guy needs to multiply by x. Cool? Great. What is x times x? X squared. Agreed? Okay. What is this guy right now? X. What does he need to be? 4x. He's already got the x. So what must he multiply by? 4. What's 7 times 4? Minus 28. Yeah? Okay. And what is this guy's denominator? 1. What does it need to be? 4x. So what does this guy need to multiply by? 4x. What's 3 times 4x? 12x. Is everybody okay to there? Yes? Is everybody okay to there? Yes? Okay. Let's rewrite this in something that we like. X squared minus 12x minus 28 over 4x. Is everyone okay with that? Does everyone see what I have done there? Because I didn't explain it. I just did something. Does everyone see what I did? Now, you could put equals to 0, yes. Does everybody see what I did there? If you don't see it, I'm going to do the next thing. I'm going to put that there. Is everybody cool with that? That's all I did. Does everybody see what I did there? Okay, now I'm going to do something really weird here. Why did I just cross that off? Everything's been multiplied by the common denominator, yes? So it's actually what now? It's just the top that I need to find, yes? Because everything has been multiplied by this, this could be divided by 4x, couldn't it? If you knew how to divide polynomials, we could divide this by 4x and we'd be okay, wouldn't we? Does everybody understand that? Once I get my common denominator, I need not care about it anymore. If you don't believe me, I can get a fraction question out and show you with no variables. But is everyone okay with that? Okay, so what would you do with this now? Step 4 is we use regular algebra. So what am I going to do with x squared minus 12x minus 28 equals 0? How do I solve that? You factor it to get what? X plus 2 and x minus 14. Yes? And just like quadratics, what must x be? Negative 2 and positive 14. Am I done? I need to check. Is either of those answers one of our non-permissible values? No, so we're okay there, right? Now I need to check if they're extraneous. What is negative 2 divided by 4? Negative 1/2, yes? Negative 7 over negative 2 is positive 7/2, yes? Is negative 1/2 plus 3.5 3? Yes. 7/2 minus 1/2 is 6/2. 6/2 is 3, yes? So is 2 okay? Excellent. 14. 14 fourths minus 7 over 14 equals 3. 14 fourths is 7/2, yes? Minus 1/2, yes? Is 7/2 minus 1/2 3? Because that's 6/2. 6/2 equals 3. Is everybody good? Ranveer? Of course. Is everybody good? That's all you do. Nothing changes except the terms get a little more complicated. So let's look at this first one right here. Is there any factoring to be done? There's 2 spots that can factor, yes? Where are they? 2, z plus 2. I shouldn't have used z. Plus 10 over, what's coming out here? What stayed in? Z plus 2 equals 1 over z minus 2, yes? What are our non-permissible values? Plus or minus 2. Is everybody cool there? Stop me if you're not, because this is not difficult, but it is complex, yes? There's a lot of math going on here. So stop me if you are uncomfortable. All we've done is factoring. There's been no special factoring. It's just like grade 10. Everybody cool? Factor, factor, factor. Everyone is good, yes? All right. Now, what is our common denominator? That's everything I need on the bottom. So I need a 6, z plus 2, and a z minus 2. What does this guy have? You could. If you knew what you were doing, I would say that. But since for most people, they're seeing this for the first time, I'm going to do every basic step. So what is missing in the yellow one? The 6. So what does this 2 need? A 6. What's 6 times 2? 12. Excellent. Plus, what's missing in the blue one? Z minus 2. So what does the 10 need? Z minus 2, which is what? I'm going to write it as 10z minus 2. Everybody cool? There's a reason for it. Trust me. What does this side need? 6 and z plus 2 times 1. So 6 and z plus 2. Is everybody okay with what I have here? Everyone. Look at it for a minute before you decide. Is everyone okay with it? Everyone's good? Okay. Once everything is over the same denominator, do I need the denominator anymore? No. So what I have now is 12 plus, 10z minus 20 equals 6z plus 12. Is everybody cool with that? I just expanded everything out. Is everyone good? And the bottom gets to cancel because once everything is over a common denominator, we're fine. We don't need the denominator anymore. Okay? Now, what would you do with this? Algebra. 10z minus 8, yes, equals 6z plus 12. Then we solve. 4z equals 20, and z equals 5. Is that one of our non-permissibles? Nope. And we can check real quick. What's 5 squared? 25 minus 4, 21. Ew, I don't want to check that, do I? But can I check it here without the fractions? Yes. 12 plus 50 is 62 minus 20 is 42, yeah? 6 times 5 is 30. 30 plus 12 is 42. Does 42 equal 42? So we did it right. Is everybody good? Is everyone good? Now, guys, I know it seems weird, but it's not. It's everything you've ever done in math in one question. And I've been warning you all year that this is where we are going, yes? Now, Lucas made a statement right here. Couldn't you simplify this 10 and 6? Go ahead. Make that 5 over 3. It will still work. Okay? I'm only showing you, like I have always taught math, the way that will always work. I leave it to you to find the shortcuts. Because if I teach them to you as a shortcut and you forget the shortcut, then you're screwed, aren't you? But if I teach you the long way there, you can find your own shortcuts. Yes? So let's look at this last one. What can I do? There's some factoring to be done, yeah? Where? 4k minus 1 isn't changing. Minus k plus 1 isn't changing. K minus 2 isn't changing. But this one is. What's this going to become? Does it factor, Lucas? It doesn't. It looks like it should factor, but it doesn't, does it? So what do we do when we can't factor it? You leave it alone. K squared minus 4k plus 24 over, but this can factor, k plus 2, k minus 2. What now is my common denominator? The whole thing, k plus 2, k minus 2, yes? So now I'm going to start giving you guys some shortcuts. We know the denominator is going to disappear, yes? So let's take care of our non-permissibles first. We know the denominators are going to disappear, yes? But before they disappear, I need k plus 2, k minus 2, correct? What do I have there? K plus 2. So what does this guy need? K minus 2. What do I have there? So what does this guy need? K plus 2. And this guy already has everything. So does he change? No. So what do I get? Once I have done this, do I care about my denominators? No. They're gone. So now all I got to do is do this. 4k. Now I'm going to write this all the way out because I'm teaching you guys how to do this. Do you think I would write this out if I was doing this myself? No, I would FOIL that in my head. Minus 4k minus 1. Sorry, Bryce, thank you. 4k minus 1. And this is k plus 2, k plus 1, all equals k squared minus 4k plus 24. Yes? FOIL those. What do you get? (4k squared minus 8k minus 1k is minus 9k plus 2. Yes? Any problems with that? Grade 10 FOIL, we're all good. Minus, grade 10 FOIL, k squared, 2 plus 1, 3k plus 2 equals k squared minus 4k plus 24. Now what do you think? Again, nothing new. You already know how to do this. Subtract them. 4k minus k, 3k squared. Negative 9k minus 3k. Negative 12k and 2 minus 2. 0 equals k squared minus 4k plus 24. Now what?
Why is it 12k?
Because negative 9k minus 3k.
Oh, gotcha. Minus 1.
Now what? Collect like terms. So this k's got to come over here, yes? To get what? 2k squared. Now my k squareds are gone. This k's got to come over here to get what? Minus 8k. And this 24 has got to come over and get what? Negative 24, all equals what? 0. What are you going to do with that trinomial? Factor. What's the GCF? Out comes 2. K squared minus 4k minus 12 equals 0. Then what? Right. K plus 2. K minus 6 equals 0. And what's k have to equal now? Negative 2 or positive 6. What's wrong with that? Can't equal negative 2. So is this allowed? Nope. So what's the answer? K equals 6. Is everybody good? Please notice it's a lot of work, but also please notice there's nothing new. Could I have taught you this if you were in my class in grade 10? Could we have done this at the very end of our factoring unit? We could have, couldn't we? Because nothing new. Right? Nothing new. Is everyone okay? All right, now listen. The next page in your book, 137, is a page of practice on this with no answers. I owe you guys 2 keys, right? I owe you the key that I forgot on the long weekend, and I owe you this key. Yes? Okay. So I don't want you going on to 138, because 138 is going to take what you just learned, and we're going to use it in practice. Okay? In real life situations. The math that you can use to solve problems that real people that use math use. But before we do that, you need to be real good at this. To be real good at this, you need to be real good at what we did last week, which I didn't give you a key for, so you don't know if you're good at it or not yet. Yeah? So here's what I suggest to you all. Start on 137 right now. Okay? I will very rapidly write up the key to 132. Okay, just that first page. Everybody with me? Then you can go back and check right now, make sure you're doing it right. Then I'll put up the rest of that key today on my prep. Okay? Everybody cool? Okay, go. Now, do you guys mind awfully? Oh, never mind. Carry on.